All right. Hello, everyone. I'm Bernd, and today is day 13 of Advent of Code. So today's puzzle was about comparing packets and checking whether they are in the right order or not. So what is a packet? So a packet in this example is a list, and all the elements are either lists themselves or they're integers. And then how do we compare two packets? So we compare them element by element. So if you have to compare two lists, if the first elements are both lists, we compare them again the same by comparing the first element, second element, and so on. Otherwise, if they are two integers, we just the order we return the order depending on the size of the integers. If they're mixed, one of them is a list and one of them is an integer, we take the integer and create a list from it that has as only element this particular integer, and then we use that to compare the two lists that we now have. Yes, and for the input, we're given pairs of packets, and then we want to compare and check whether they are in the right order or not. So how can we do this with code? So of course, we need to read the file and spin into lines. And then in order to make a comparison more readable and to know what we're doing, we define this enum where we have first with values larger, same, and smaller, so that we can return something like for first, larger, and so on. Then we split the comparison function into a few separate functions. So first we want to compare two integers. So that's done by size. So if a is greater than b, we return first larger. If a and b are equal, we return that the first is the same, and otherwise we return that the first is smaller. Comparing to lists is a bit more complicated. So as I said, we go through all the elements and we stop as soon as the shorter list runs out of elements. So conveniently that's done by the zip function, which returns the pairs of elements. And then we compare the elements themselves. If the elements are the same, we'll have to look at the next pair of elements and continue. Otherwise, we know that the relation between the whole lists is the relation of the elements, and we can return that. So what if we run out of elements to compare and all elements are the same? Then the comparison is made based on the length of the list. So if the length of A is larger than the length of B, we return that the first list is larger, and so on. Okay, with that we can compare two objects of any kind. So we compare where A and B could be either integers or lists. So we check if both A and B are integers, then we can return the result of the integer comparison. Otherwise, at least one of them will be a list and one of them might be an integer. So if one of them is a list and one of them is an integer, we're told that we have to convert the integer to a list in this way. So we check for both of them if they're not a list, and then we'll convert them into a list. And after this, we know that both parts A and B will be lists, so we can compare them as lists and we return that result. Okay, with this we can solve the problem. So we're told the solution depends on the index of each packet, and depending on the comparison between them, we either add it to the solution or not. So we go through all the indices, then the strings corresponding to the packets are given by these lines at these indices. And then we want to take the string and convert it to some actual Python object, like a list containing integers and other further lists. We can do this by evaluating the corresponding string. And this gives us packet 1 and packet 2. And then we figure out the relation, and the problem tells us if the relation is that the first is smaller, we're supposed to add the current index to the solution. Okay, so we can test if this code runs reasonably well on the test input. So that looks promising. So we can also run it in the real input, and it also turns out we get the right solution. Part 2 is slightly different. So in this case, we consider not pairs of lists, but we consider all the lists and even two extra lists. So the two extra lists are given by this list that contains a list that contains 2 as the only element, and the list that contains a list that contains 6 as the extra element. And then we want to sort these lists depending on the relation again we had in the first part. And then depending on which positions these so-called divider indices are, that will be a solution. So from the first part we can reuse a compare function. And we again define all the packets by evaluating the string that's corresponding in a line for each line if the line is not empty. And then we add the two packets we're told, the two divider packets. we will sort we keep a list of all the indices, and we'll sort these indices based on the packets and how the packets compare to each other. And we will also save the two indices of the divider packets so we can access them later more easily. Okay, so we will need a function to compare indices. So how do we do that? We first take the corresponding packets, the packets corresponding to the indices, then we compare them, and this will return -1 if the first is smaller. And this -1 tells us that the first index should go before the second, and otherwise it will return 1. And then we can sort this list of indices based on this comparison function. We need this little comparison to key function in order to be able to do that, but with that we can easily sort the list of indices, and then the first index in there will correspond to the smallest packet, and so on. And then a solution will be we just go for the indices, and if the index is one of the two divider index, we'll add or we multiply the solutions with the corresponding order with the position where this index is in the list. Okay, that's already it for part 2. You can run a little test, and that also looks very promising, so we can also run it on real input. And that is already it for day 13. I hope you enjoyed today's puzzles. Best of luck for the future, and see you around.